Hello, in this video I'm just going to go through a couple of the skills requirements that you'll come across in this exercise. The first one is I do ask you to give me exact answers, and that's very important. So the question is, what is an exact answer? An exact answer is where you don't write a decimal. So let me give you some examples. So we're all familiar with this question right here. If I said, what's the length of this line segment here, you would say 1, and then I'd say I have 1, 2, 3, 4a. So you'd say plus 4a. And we'd be okay with that. Well, what if I asked you the length of this line segment? Well, what some students would do is they get their calculator out and they'd say 1 plus, and they take the square root of 3 and add it together. But you get a decimal, so it would be approximate. So the exact answer here would be 1 plus, and you just write the square root of 3 and you just leave it like that. That's perfectly acceptable. I could have a situation where I have, say, let's say this is a length of 1 centimeter, and then let's say this is the length of root 3 centimeters. And this is the length of root 3 centimeters. So now, again, it can look a little intimidating, but it's just like this first problem up here. So that means it's going to be 1 plus root 3 plus root 3. And then I can say to myself, well, how many root 3's do I have? I have 2 of them, so it's 1 plus 2 root 3. There's my exact answer. If the value under the square root sign is the same, you can add them together just like that. So for example, if I had something like this, where this was, say, 1, this was a length of root 3, and let's say this was a length of root 5, this would be 1 plus root 3 plus root 5. That would be an exact answer. I can't add root 3 and root 5 together the way I added root 3 and root 3 together. So again, exact answer means if you have a root value and you get a decimal, just leave it like that. Next skill requirement we want to make sure we're comfortable with is root reminder. So a root reminder is that if I have the square root of a times the square root of b, that's like saying the square root of a times b. So an example here is if I have the square root of 3 times the square root of 2, that's like saying the square root of 3 times 2, which is the square root of 6. So a case we'll come across quite regularly is if I have the square root of a times the square root of a, that's the square root of a times a, which is the square root of a squared, which is simply a. So root 5 times root 5 is root 5 times 5, which is root 25, which is 5. So we want to make sure that we're comfortable with the fact that if I multiply the same root by itself, that's going to result in whatever's under the root symbol. So if I have root b times root b, that's simply going to be b. If I have root 3b times root 3b, this is simply 3b. Okay? The next skills we want to make sure we're comfortable with is expanding brackets that have roots. So if I have something, for example, let's say 4 times 1 plus square root of 2, that's like saying 4 plus 4 times root 2. And again, I can leave it just like that. If I wanted to, I could get my calculator out and work out the approximate value, but in this case, I want exact value, so I'd stop. So I just took the 4, just like a normal expansion. 4 times 1 is 4, and then 4 times root 2. I can't actually work that out to an exact value, so just leave it like that. I could have an example where I have, say, root 3 times, let's say, 3 plus root 3. Well, in this case, same idea. I'm just going to multiply it in. So I'm going to end up with, well, 3 times root 3, because, again, 3 times root 3, I don't know what that is exactly. We usually write the constant in front. And then now I'm going to say root 3 times root 3 is going to give me the square root of 9, which is simply 3. Okay? The last skill that you might come across is expanding binomials that have roots. Now you won't necessarily come across this, but I do want to include this just in case, because we know how to expand binomials. If I gave you something like, for example, 1 plus a times 2 plus b, you would simply say 1 times 2 is 2, 1 times b is b, a times 2 is 2a, a times b is ab. We just simply take everything in the first bracket, multiply by everything in the second bracket. Easy. Well, I could have radicals in there, or roots, as we're calling them right now. You might hear this word radical, and that is correct. These are radicals, but we're not actually interested in defining those yet. So let's say I have 1 plus root 3 times 2 plus root 3. Okay, so I'm going to now work through this. 1 times 2 is 2. 1 times root 3 is root 3. Root 3 times 2 is 2 times root 3, right? Root 3 times root 3 is going to give me 3, right? So just let's make sure we see this. We did 1 times 2 is 2. 1 times root 3 is root 3. Root 3 times 2 is 2 root 3. And root 3 times root 3 is 3. And now what I do is I group my like terms. So if I have 2 and 3, that's going to give me 5. And then root 3 plus 2 root 3 is going to give me 3 root 3. And I'm done. Okay? So these are a couple skills you might come across. We've talked about these in class before, but we want to make sure we're comfortable with them as you head into this folding exercise. Good luck.